Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry: The Mystery of Molecules. Today's topic of discussion is one MCQ which is in front of you. I request you please pause the video, write your answer in the comment box, and definitely after some time you will get the right answer. But remember student, self-evaluation is essential for improvement, and for that purpose you need to try. Now let's come to the explanation. Before going to the details, I request you student please read the question. There are three steps, step 1, 2, 3. These three steps are easy, you know, but you need to understand, and in this case I should write, I request you please write every step along with me. I am teaching, it will be helpful. Now first step, bromine in acetic acid. What happens? Bromine in acetic acid means acidic medium bromine, that is substitution of alpha hydrogen of the carbonyl, because this compound has a keto-methyl group. So it will react and one bromo will be substituted because it is an acidic medium. If it is alkaline, then 3 bromo. That's a haloform reaction. Now this is the first step, monobromo derivative. Then it's react with sodium sulfide, 0.5 equivalent. We know sulfur is a softer center, good nucleophile, and in this case sulfur is 2 minus. So first step, what it can do? First step, this bromo could be replaced by this S minus. Since I have taken half of sulfide, so this sulfide can react with another such kind of molecule and dye substitution possible. So this is, so you may consider this is actually a SN2 type reaction to produce this disulfide substituted derivative. Means and remember student, this SN2 reaction on alpha halocarbonyl is easier because of the presence of this carbonyl group which participates and reduces the LUMO energy. I have already discussed in a dedicated video, you may visit for better understanding. Now what is the third step? Third step is sodium methoxide in methanol. Sodium methoxide is a base because it's an alkoxide, and see it's an dialdehyde, means 1,2-dialdehyde. First of all aldehyde, second position is 1,2, means highly electron deficient, and the strong base can abstract proton from the alpha hydrogen here, means this proton could be abstracted because first of all alpha of the carbonyl, second this sulfur also have some minus I effect. Not only that, it has d orbital which can stabilize the carbon ion produced in this position. So means it's a relatively stable carbon ion, so it will be produced under this condition. Next step, these carbon ion will act as a nucleophile, means it will attack here, and since it's an 1,2-dicarbonyl, so electron deficiency is more compared to single carbonyl because minus I effect of carbonyl, means one carbonyl will provide its minus I and activate the other one. This is the truth. Second thing is aldehyde, so there is one hydrogen, and hydrogen is lesser bulky, so consequently nucleophilic attack will be easier, and the concept associated with this process is called Burji-Dunich trajectory or Bargy-Dunich trajectory. I have already discussed a dedicated video on this, you may visit for better understanding. So it will open up after nucleophilic attack, fine, and so after proton obtained from this methanol solvent, it will produce this. And by the way, I have showed this option, so it's a change, but remember this is a symmetrical compound, so it doesn't matter. So one side will be substituted and this is the OH. Now in the second step, there is also another proton here, so in presence of the base means same condition. What you can expect? Similar thing, means this hydrogen will be subtracted, it will produce an carbon ion, and through a intramolecular, the first one was inter means different, and right now inside same molecule, so intramolecular reaction it will open up, and after the same step it will produce this string. Now question 5, 5-member ring. Now count the position, 1, 2, 3, 4, 5. And student, I always request please follow this numbering. First do numbering, second do the reaction, because after this numbering you draw one 5-member ring and 4 position is thiophene, means sulfur, fine. In the next there is 5, and so here 3, 2, 1. Now already 2 position have hydroxyl, so no issue, it's fine. 1 position will produce hydroxyl. So in this way you can end up the right structure, and 3, 5 both are carbonyl. This is, now if you look at this thing little closely, so what this compound actually is, this is actually a alpha beta hydroxy carbonyl compound, is a product of aldol type condensation. So under this condition, in terms of base, what you can expect, that this proton is expected to be abstracted by OMe, stronger base, so it will come, it will push this, And remember, in alkaline medium, OH minus is a relatively better leaving group, so it will leave. And after that, in first step, what it will produce? First step, it will produce this single substituted derivative. I'm not going other thing. This is alpha beta unsaturated carbonyl derivative. It's stable conjugated, so that's why it will produce. But in the next step, another will also follow the same strategy, means this proton and this. Okay, and after that, what it will produce? It will produce a thiophene derivative. Now question, what is the driving force? First elimination driving force is conjugation, and second is aromaticity, which is one step ahead of conjugation, means it's an extreme stability. And this is actually a thiophene derivative, 5-member heterocyclic compound. By the way, I've already discussed this thiophene derivative about this 5-member heterocyclic compound chemistry previously. You may visit for better understanding. And this way, this di substituted, better to say, you can consider this is 2, 3, 4, 5, 2, 5 di substituted thiophene. In this way you can produce. Now in this case, student, there are few name reaction associated with each steps. For example, first step is associated with alpha halogenation of ketone, I have already discussed. Second step is nucleophilic substitution on carbonyl or alpha haloketone, I have already discussed. So this is third step is cross-aldol condensation, I have already discussed. So now you can see fourth step is intramolecular aldol type condensation, and fifth one is aromaticity. Now student, you can see every step is associated with one type of name reaction, and that is the reason why you should learn this name reaction very precisely, step by step. I have already discussed many videos. I request you visit them if you have any difficulty in understanding. So this is the overall discussion. Now based on that, we can conclude what is the answer. The answer is this one, option C. Okay, now why not other? I have shown example. Now question, if this, I have explained in this case, if this question appeared in your exam less than 30 seconds, how can you solve? First of all, you need to understand what are the functional group given. This is actually a keto-methyl group given, because in our case nothing is mentioned, so you don't need to think about this R. It is bromine acetic acid. In exam hall, on your question paper, you should draw a separate structure about this, and in the right, 1 bromoacetic acid means bromo substituted. Then Na2S, I have clearly mentioned 0.5 equivalent, means half, and this S minus is 2 minus, means di substitution possible. So okay, fine. So in this way, 2 means sulfur along with 2 substituent possible. This. Now stop here. First option SH gone, process of elimination. Second option gone. Now question is whether this or this. Now I have given glyoxal NaO means OMe. Did I provide any reagent which can replace these oxygen with sulfur? I didn't provide. So how these substrates could produce? Not possible. Based on your common sense, just eliminate this. What is left? This is the answer. You don't need to think about cross-aldol condensation, intramolecular reaction, not needed. But that is smartness, and that comes after proper practice, proper study. So that's why I request study well, and I am trying my best. So in conclusion, what you have learned today, alpha halogenation of ketone could selectively achieve both in acid or alkali, but the result different, because in acid monosubstitution, in alkali trisubstitution, or more specifically say haloform reaction. Now sulfur is a softer center, that's why it can act as a better nucleophile. And this glyoxal is a very good electrophile, both from steric as well as electronic. Steric because hydrogen aldehyde, and electronic because first of all it's hydrogen plus no alkyl group there. Second, 1,2 dicarbonyl, both are withdrawing, so one activates another. And remember, intramolecular reactions are always faster than intermolecular reactions. Intra is faster than inter because of proper conformational orientation. Please remember this statement, is very important for understanding. And remember that aromaticity is a huge stabilization energy. It's actually a resonance stabilization or delocalization type stabilization. So this is the end of this discussion. I believe this video may be useful. Please write your opinion in the comment box, and I request you, if possible, please visit my another channel, Climate and Chemistry, where I upload global warming and climate change related videos. So thank you, stay happy, stay blessed, see you.